Welcome to the Oregon State University Extension Master Gardener Advanced Training Webinar Series, and welcome to the webinar on grafted tomatoes. So I want to introduce our speaker today is Dr. Cary Rivard from Kansas State University. Cary received his bachelor's degree in agricultural sciences and biology from Truman State University in Kirksville, Missouri. Cary completed his master's and PhD in plant pathology at NC State University. Cary is currently an associate professor, extension specialist, and director of the K-State Olathe Horticulture Center. His research investigates the use of grafted tomatoes for organic and conventional production. He also conducts research in high tunnels and is responsible for maintaining the hightunnels.org website. Due to a little technological glitch, the recording will be starting about 45 seconds to a minute into his initial introduction. Thank you.
Market growers that can get a pretty high premium per pound for their tomatoes are using grafted plants, and we're helping people here in Kansas and Missouri, for that matter, gain access to grafted plants. And so we're starting to see a lot of people use them, as well as the home garden market as well too. Now, there's a couple different reasons to use rootstocks and use grafted plants, and the main things are for disease management and also just increasing yield and vigor in the plant. We'll talk about that more as we go along, but there's a lot of folks in the southeast that are looking to use resistant rootstocks to manage very specific diseases like bacterial wilt, fusarium wilt, and root knot nematodes. We're not going to talk about that as much today, but it is definitely something that's going on nationwide. So if we look at grafting worldwide, it's actually used predominantly for vegetable production in Asia and also around the Mediterranean region as well. And you can see some numbers here. These are starting to get a little bit old, but you can see the scale. This is a grafting nursery in Korea. And here they're growing grafted tomatoes, grafted watermelons, grafted peppers, grafted eggplant. And so you can see the scale that they're growing these at. In Asia, they're growing millions and millions of grafted transplants, mainly for producing melons and tomatoes and eggplant, especially in high tunnel production systems. Now, this past summer, I was fortunate enough to visit a greenhouse in Greece, actually, where they were growing 15 million grafted transplants. About half of those were cucurbits, mainly watermelons, and then the other half was tomatoes. And they did a few peppers as well. You can see on the bottom picture here, they were actually using indoor healing chambers with LED lights in them. It was pretty cool, kind of space age technology, but again, the massive scale that these folks are producing these grafted plants is really quite a feat to see. The other thing that's kind of fun about growing with grafted plants is you can do neat things, and especially in the home garden. So Brooke may recognize this picture. I threw this in just for her. This is my son, Samuel. Samuel just turned 14. He has his driver's permit actually here in Kansas, so he's driving a car, which is a frightening thing. But when I was in graduate school, I got so bored one night in the Phytotron that I actually figured out how to graft two scions onto one rootstock. So this was actually a German Johnson and a Cherokee Purple scion grafted onto, I think it was a Beaufort rootstock in this case. And what we did was we actually stacked those stems on top of each other instead of making a Y, and then just let the branches shoot out. But, this isn't something a commercial grower would do, but it is something fun you can do at home. I could see people grafting together cherry tomatoes and heirloom tomatoes or beefsteak tomatoes so that you can have one plant producing two different types of fruit. The other thing that we won't talk about in any great detail today, but just wanted to let you know what was going on, there's also a lot of interest in the US and a lot of use of grafted cucurbits. So these would be cucumbers, watermelons, cantaloupes, but especially watermelon and cucumber. And they're doing this a lot in the Mediterranean region to deal with salinity in soils. And then also, you may or may not know that the cucurbit family is extraordinarily sensitive to cool soils. And so we can graft cucumbers onto fig leaf gourd rootstocks and some other wild cucurbit species that can be a little bit more tolerant of those cold soils and really increase early production. So there's specific reasons that they're doing that in those situations as well. So let's talk more specifically about tomato grafting. So the first use of grafted tomatoes started back in the 1950s. The first vegetables to actually be grafted were melons, and that was in the 1920s to deal with fusarium wilt. But in the 1950s, they started grafting tomato mainly to manage a disease known as bacterial wilt, which is caused by Ralstonia solanacearum on tomato. It also causes that disease on tobacco and pepper as well. Now, this is a very interesting disease in the world of tomatoes, and one that I studied a lot when I was in graduate school, because it actually, the resistance genes for bacterial wilt are tightly linked to fruit quality genes. And so what that means is there's lots of tomatoes out there that have resistance to bacterial wilt, but there was very few of them that actually produced a nice, good, edible size, marketable tomato. And so somebody back in the 50s said, well, let's just take one of these wild species that are resistant, graft it with our favorite variety on top as the scion, and the scion's going to be the fruit-producing variety, right? And then voila, you have a plant that has the resistance characteristics and the root system that we're looking for disease management, and then the fruit-producing characteristics in the scion, or the top portion of the plant. And so that system has worked really well to manage that disease, and is one of the reasons why grafting has started to become adopted here in the US as well. Now, what they figured out after they learned to graft tomatoes is that we can also find rootstocks that have added vigor or resistance to other pathogens as well. So now there's a whole host of reasons why people graft tomatoes, you know, in addition to trying to manage abiotic stressors as well, like soil salinity or high temperatures in soils. So, you know, when I think about the benefits of using grafted plants, what you're really adding is you're adding a new root system, right? And so we can think about the benefits of grafting as the benefits of the rootstock, or more specifically, the function of that rootstock in particular. So again, the root system is going to be an entry point for pathogens in the soil, right? So fusarium wilt, nematodes, you know, verticillium wilt is probably one that's more common in Oregon. These are all things that infect the root system of the plant and then cause disease. So if we can put a resistant rootstock underneath of that plant, we can manage that disease more effectively. And then the other thing is that the root system, of course, is important for water and nutrient uptake, and can add a lot in terms of vigor to the plant and the way that it grows and the characteristics of that above ground production. And last but not least, the root system is also an interface with the soil ecosystem. And so we've been doing some research here more recently. In fact, we just published a paper looking at some of the microbial ecology of the plant, and I'll show you that here in just a minute. So a little bit about the research program that we have here at Kansas State University. Again, as Brooke mentioned, this is something that we started back when I was in graduate school at North Carolina State, and has just sort of snowballed out of control really ever since then. But you know, we like to focus our areas in four main focus areas. And first of all is, how can we produce a grafted plant in a simple, easy to use method for our small acreage growers that we have here in Kansas and the Midwest. And then we also do a lot of rootstock evaluation. And so we put out on-farm trials and things like that to determine what rootstocks are most effective in our area. Most of these are going to be in high tunnel systems. And then again, we're looking at some of these rootstock microbe interactions as well. So in terms of field trials, you know, this could just give you an example of, you know, the kind of work that we're doing. This figure, I think, is actually from a couple seasons ago, but in that situation, we had, you know, a good number of on-farm trials as well as trials here at the research station as well. And we've had a lot of great graduate students that have helped with that program. This is just a picture from one of those on-farm trials. This is a local high tunnel grower here in Johnson County, Kansas. And so we'll take the truck over there, harvest tomatoes, get our yield data, and then pack up the boxes and hand them over to the farmer and head on our way. So through these rootstock trials, we've been able to identify some rootstocks that provide added yield even when there's little to no disease pressure. And this is an important question for our growers here in Kansas, and I think in your part of the world as well too. Not everybody has really severe diseases like they do in the Southeast, right? And so what are some rootstocks that actually provide enough added vigor that they can increase the yield of those plants even when there's no disease present? And so you can see this list on the left is basically the rootstocks that are more consistently successful at providing a significant benefit as it relates to marketable and total yield. And Maxifort is one of the most common rootstocks that are utilized by growers here in the US, but there's a plethora of other rootstocks that are available as well. Now, most of these rootstocks that we're working with are what are called interspecific hybrid rootstocks. And so what that means is it's actually a cross between a wild and a domestic species. So it's a little bit different plant, and I'll show you an example of that here in a little while. Another thing that we've been doing is we've actually flipped these trials on their end a little bit and have been doing some trials where we keep one rootstock, in this case Maxifort, because it's one of our more successful ones, and then we look at it with different types of scion. And I'm not going to go into the details of all of this, but what we've found that I think is really interesting is that very consistently we're finding certain scions actually respond better to the use of some of these vigorous and vegetative rootstocks than others. And so it's really interesting to me that, you know, not all scions, you know, the utilization of these rootstocks is not an additive effect. It seems to be more of a synergistic one. Whereas with certain scions, we see, you know, you can see with Tasty Lee, we had 60 to 70% increase in yields, right? So that's a pretty significant change. Whereas with Primo Red, we only saw something like a 10% increase in yield, right? And that was actually consistently across 2 years of collecting field data. So it's really interesting that there are definitely some complex interactions that are happening between these rootstock and scion varieties. So what we're trying to do with some of this research is really get a hold for what is the plant vigor. You know, I spent a lot of my graduate career, and there's a lot of work still being done in the Southeast looking at specific diseases that can be managed with some of these rootstocks. But what we're really interested in is seeing how they affect plant vigor and how they increase yield when there's little disease present. So we've started to get a feel for, you know, some of these rootstocks and how they're able to add that vegetative growth as compared to just disease management in particular. The other thing that I mentioned before is that we're also finding out that, you know, in order to try and determine why some of these rootstocks may be more vigorous than others, we've been looking at some of the microbial ecology of the rootstocks themselves. So this is some work done by a PhD student in the plant pathology department. And what he was able to find out is that actually with some of these rootstocks, we're finding different groups of bacteria that live on the surface and within the root system of the actual plant. So, you know, it's an interesting thing, and it's not necessarily surprising. Again, these are wild species of tomatoes that are crossed in with standard hybrids. And so, you know, it does make sense that probably the bacteria that associate with them might be a little bit different. But, you know, one thing that's interesting is possibly because they're so much more vegetative, they're probably providing more of a food source to these microbial communities. And what could be happening is as a result, we've seen that there is actually a higher microbial diversity in the root system of these grafted plants as compared to our non-grafted controls. And so that's kind of an interesting finding and a new finding that we just published earlier this year. And then last but not least, I did want to, you know, just mention a little bit about the work that we're doing with the post-harvest physiology group here in Olathe, and that's to look at actually the effect of fruit quality when we start utilizing these grafted plants. It's one thing if you can grow a bigger, better tomato, but it's important that it still needs to taste good, right? And it still needs to be healthy for the consumer. And so we work with a collaborator here, Eleni Pliaconi, in her lab, and they're actually looking at lots of different aspects of fruit quality in terms of shelf life, as well as nutritional quality and visual quality as well too. So just a little bit of that data. This is actually the Brix levels of some of our grafted and non-grafted plants. And you can see that there was basically no significant difference in the Brix levels. Now the Brix is basically the total soluble solids, so it's the sugar levels within the tomato. And you can see that there was basically no difference when we use these grafted plants. Now keep in mind these grafted plants are providing more yield in these cases in these trials, but at the same time at a similar sugar level. Now, what could change the flavor a little bit is we are seeing a slightly higher acidity levels in the tomatoes. And so that actually will, you know, physiologists basically look at the acidity to sugar ratio when they talk about flavor. And so we are seeing a little bit higher acidity with some of these, but that may be something that some people like in tomatoes, right, too. So it's not unusual to see some fluctuations there. One of the things that I found really interesting about this data too, and these are some tomatoes that were grown in a high tunnel, basically with different kinds of rootstocks, is that we did look at the antioxidant capacity, and that's one aspect of nutritional quality of these tomatoes. And there's this predominant theory in the great world of agriculture that whenever we start increasing yield, we reduce our nutritional quality, right? And we kind of think about agricultural crops as we breed for higher yield. Oftentimes, the nutritional density of those plants will go down, and that's something I think a lot of people assume happens, although we don't really know if that's the case. But it looks like with the use of these vegetative rootstocks, that we're actually getting similar levels of nutritional quality. We found with our highest producing rootstock, Maxifort, it actually had very similar antioxidant capacity to the non-grafted plants. So that's encouraging that we're able to increase yield without penalizing the nutritional quality of the plants. What's also really interesting about this study is if you look at the two bottom rootstocks, RT1028 and RST04106, these are actually rootstocks that are, I would call them low performing rootstocks, in that they actually didn't increase yield significantly in any of our trials. But what they did do is they actually increased the antioxidant capacity of the fruit that were coming off of those plants. So it's really interesting to find out that there does seem to be something going on as we change the yield capacity of these rootstocks. It affects nutritional quality, but it looks like the ones that give us the best nutritional quality are the low yielding rootstocks, and our high yielding rootstocks are still similar to non-grafted plants. Excuse me. So let's talk about the actual propagation process itself. So this is a picture from one of our healing chambers in the greenhouse. We do a lot of grafting here at the research station. We actually built a greenhouse specifically for grafting tomatoes, and it's designed into different kinds of chambers where we can put different environments that allow us to manipulate the growth rate of the plants and then have an ideal situation for our healing chambers. We started doing custom grafting services for our farmers here in the area about 3 years ago. And so this past year, I think we're producing somewhere around 10 to 12,000 grafted plants in our greenhouse. So we've done quite a bit of it, and we get a lot of good help. I've got a great crew of folks that work at the research station with me, and they, excuse me, and they do an awesome job helping to really manage this thing. So before we get into the logistics of grafting, I did just want to put a couple of disclaimers out there. Keep in mind that there's a lot of difficult aspects of growing a grafted plant. And the hardest one is probably not what you would think. The hardest thing to really figure out how to do well if you want to grow grafted tomatoes is you have to figure out how to get the stem diameter of one plant, the rootstock, and another plant, the scion, match on the same day. The slicing and dicing is actually the easy part. But in order to get those stem diameters to match up, you have to be able to manipulate and manage the growth rate of those plants, or have a perfect system lined up and stagger your seeds. And we'll talk a little bit more about that later. But being able to manipulate that growth rate is a key principle of success for growing grafted plants. The other thing is, keep in mind, you've just taken a plant, cut it in half, put it together with another plant that it takes about 7 to 9 days for the graft union to heal, is what research has shown. And so you have to figure out a way to keep the upper portion of that plant, which is the scion, alive for those 7 to 9 days while that graft union is healing. And that's the real challenge of growing a grafted plant, is basically to get it through that healing process. And the graft union really forms on its own. So, having a good understanding for what drives water stress in the plant and how you can manipulate the environment is really important. And then last but not least, keep in mind that when you put these plants into a healing chamber, we're going to raise the humidity, we're going to reduce the light, and so you're putting them in a really ideal situation for diseases. And so it's really important to use good sanitation methods, always be putting clean, healthy plants into the healing chamber that aren't going to cause a problem once they get to that high humidity environment. So we're not going to talk about grafting technique for cucurbits today, but I did just want to show you a nice diagram. This is actually a pretty old diagram from one of the pioneers of vegetable grafting in Japan, and you can see the different methods that are used for cucurbits. As far as I know, the whole insertion method is probably one of the most popular by commercial grafters for cucurbits, and there's a researcher at Clemson named Richard Hassel that's done a lot of work with cucurbit propagation. And so if you have any interest in that, I would look up some of his work. But my understanding is the whole insertion method is one of the most popular for cucurbits. We have done some cucumber grafting around here, and we've had fairly good success with the whole insertion method as well as the splice method. You can actually buy tube clips for cucumbers, which are kind of fun. Now for tomatoes, we by and large are really just using the tube grafting method. Now the tube grafting method is very, very simple. You basically cut the plant in half and you put it back together. And I know that sounds silly, but that's literally all you're doing. There has been some research that's been done that's shown that you want to cut the angle of that tomato somewhere around 70 to 75 degrees. And what that does is it really just maximizes the surface area given the size of the clip that you have. Now, tube grafting became popular in Japan. It's also called Japanese top grafting. It's more recently, I think a lot of people, especially on the West Coast, are calling it splice grafting, but it's pretty much all the same. And you basically are going to end up using one of these silicone clips to hold that plant together while the graft union heals. Now, one of the reasons why people use it so much is because it's a very quick method. We can usually, most of the experienced folks that I work with here can graft about 200 plants an hour. And so you can really crank them out pretty quickly. And the plants are small, right, when you do this. And I'll show you some better pictures here in a minute. But we typically think about them being grafted at the 2 to 4 leaf stage. Now, something that's just kind of fun, I thought I'd show you this picture. This is actually a grafting robot that's down in a USDA lab in Florida. And there's several universities and companies in Asia that are developing grafting robots. And my understanding is they use them quite a bit over in Japan and Korea for grafting tomatoes as well as cucurbits. Now, this machine could graft 700 plants an hour, but it also took 3 people to run the machine. You can see there was a person inputting scion and rootstock on either side, and then there's going to be a person that's receiving those grafted plants as they come off this green conveyor belt. So, you figure you multiply 3 people by 200 plants an hour, you're probably still in a pretty similar range as the robot, but it's still something kind of fun that's going on. So this figure shows our overall timeline, and depending on what part of the country you're in, this can change. I actually generated this figure when I was living in North Carolina, where they get a little bit more sun than we do here in Kansas. I would say here in Kansas, our timeline is more like 6 to 7 weeks, depending on the time of year. But you can still get the basic idea of the process from this figure. So, there's a couple things that you're going to want to keep in mind. First of all, your rootstock and your scion may grow at different rates. And so oftentimes we will actually stagger the seeding of those rootstock and scion to try and make up for that. Now this figure shows that rootstocks are planted first and scion are second. That's not always the case. With some rootstocks, they pop up really fast. Others come up really slow. Same thing with some of the different scion varieties. You'll find if you get to become a grafting nerd that you'll figure out that there's actually quite a variation in the number of days from the time you sow a tomato seed until the time that it pops up and actually emerges depending on the variety. So you really just want those things to emerge more or less on the same day or at least within a 2-day window. And hopefully if you transplant them at that point, then they'll be good to go. Now, most of our grafted plants we're grafting when they're exactly 21 days old, and that's from the point when we seed them, and we transplant them when they're about 10 days old. So they'll spend somewhere around 10 or 11 days in a plug tray, essentially, before they're grafted. And then in our case, ours are spending more like 7 to 9 days in the healing chamber. Now, once they go into the healing chamber, I'll show you some examples of that here in a second. But the healing chamber, you're going to want to greatly increase the humidity, and then you're going to want to cut down as much light as you can, especially within the first 24 to 48 hours. You want it almost completely dark in there. Now, once they become sort of acclimated to their new environment, you do want to reintroduce some light, and you want to be careful that you don't just keep them in the dark for too long because they can stretch out, or sometimes they'll just get stuck and they won't grow altogether. So it is important to start to back down that light, and I'll show you some examples of how we do that here in a couple minutes. Now, when you're growing the transplants prior to grafting, it's really important to make sure that you can grow a nice uniform crop. And that's really just going to make your life a lot better when it comes time to actually grafting the plants. If you're grafting, for your own use, for a home gardener, you may be using lower numbers. Do your best to, maybe cull out some of those small shrimpy guys when you transplant them, or some of the really big ones. And you might want to grow extra plants so that you can pick the sizes that you're looking for when it comes time to start grafting. You'll find that rootstock seed is quite expensive, especially if you're buying it in low numbers. And so there's nothing wrong with having some extra scion seed. You can always use those for non-grafted plants later. Now, in terms of grafting success, we usually get, and we've had batches that we've had 99 to 100% success, but that's obviously not going to happen your first time. But generally you should be able to easily get 50 to 60% success even on your first time. And with tomatoes, they're much easier than cucurbits in general. And so most people that once they sort of get the swing of it, that are decent plant propagators, will get 80 to 85% success without having to work too terribly hard at it. Now, again, it's really important to make sure that you've got healthy, clean plants going into that healing chamber. And then that healing chamber has to be set up before you actually start grafting, because you don't want those things to wilt while you're trying to set up your humidifiers and all that kind of stuff. Okay, so here's what the plant would look like on the day that we actually graft it. You can see it's a pretty small seedling. I usually tell people 2 to 4 true leaves. And that can range a little bit. And you can buy those clips in different sizes. And you can buy grafting clips at several different seed companies, as well as horticultural suppliers as well. We usually get the 2.0 millimeter clips, but they also have 1.5s, and there's even 1.2s. And I think anything between that 1.5 and the 2s work well. I think there are a few companies that are now selling 1.7s, and those are kind of nice too. But you'll just want to make sure that you keep an eye on those plants as they're growing to make sure they're the right size for the grafting clip. There's a very short window of when the plants are the right size when they're ready to be grafted. And tomatoes at this stage of their life are growing extremely fast if they've got high light conditions, right? So you want to make sure you're ready to go. You've got your clips and your knives and everything really before the plants start to grow and take off. Now, if you do have a rootstock or a scion that's getting bigger than its counterpart, one thing that you can do is you can manipulate temperature to compensate for some of these size differences. So if the nighttime growing temperature for tomato is anything much below 54 degrees Fahrenheit, then it's going to almost stop growing entirely. So what we do in our greenhouse is we'll actually go out in the mornings, and we do this almost every morning this time of year, and go out and look at our rootstocks and our scions, and then we'll actually put whichever ones are growing a little bit faster than the others, we put them into our cool greenhouse, the one that gets down to 50 degrees at night. And so that's one of the ways that we can help manage those differences in growth rates. But it is really important to make sure that you're keeping a close eye on those plants. I've seen it happen a lot of times where it will sneak up on people, and all of a sudden the plants are too big for grafting, and you don't want that to happen. So on the day that you actually graft the plants, keep in mind you're putting these poor little guys through a pretty traumatic experience. And so we want to make sure especially that they're not water stressed or nutrient stressed. We tend to do our grafting on Monday mornings here at the research station. And so on Sunday afternoon, I usually go out to the farm, and any rootstock in particular, but really anything that's going to be grafted the next day, I soak it really good the night before so that the root system is nice and wet, but the plants are not physically wet, right? And then we want to make sure we have a nice clean working area. So you can use alcohol to disinfest your tools, grafting clips. We typically clean our grafting clips with 10% bleach. And you can use that for any of your surfaces or your tables that you're working on. Again, keep in mind that you're going to be putting these plants into an environment that is really suitable for diseases to break out. So you want to make sure that you're not spreading any pathogens around as you do this. The other thing that we've learned is it's definitely helpful to graft indoors. If you're in a greenhouse environment or somewhere that's very sunny, the minute you graft, you cut those scions, they're going to start to wilt. So it's nice to bring them inside. I actually tend to bring them inside for a couple hours before we do the grafting, just to slow that transpiration process down. So as I mentioned earlier, there's actually was some research done by the USDA down in Florida, where they determined that somewhere between a 60 and 75 degree angle is ideal for grafting. We do want to graft below the cotyledon of the rootstock, right? So this is the rootstock here on the left. You can see we just use small scalpels, work really well. You can buy hobby knives at the big box stores that work just fine. But again, we're going to cut the rootstock below the cotyledon. This is the silicone clip that actually inserts over the tube, or over the stem, excuse me. And then here you can see the scion being inserted down into that clip. And hopefully those lines are nice and parallel so that that graft union is going to match together very well. Notice from this picture that you can see how red that scion tissue is compared to the rootstock. Now, oftentimes there's variations in colors on all tomatoes. If you look up the stem, they will become more red. But the reason for that was actually, in this case, our scion was growing faster than our rootstock, right? And so I took that scion and I put it into a cold greenhouse so I could slow down the rate of that growth because I didn't want it to get too big and not match my rootstock. And what happens to tomatoes when we put them in the cold? Everybody knows this, right? They turn purple from phosphorus deficiency. So I thought this was kind of a cool example. We end up with this fun tie-dye looking tomato, at least for a couple days, until the graft union heals, and then of course it all turns green again. Now once we put this down into the clip, you can see we get a nice good matchup of that rootstock and scion material. Hopefully there's not any gaps. You do want to make sure that angle is nice and parallel. And so, I think it really does help to get some practice, and you can practice with just self-grafted plants where you graft them back onto themselves. So you can, try a few times cutting that angle to make sure it's consistent when you start cutting the scion and the rootstock. So this is just a quick video. I mentioned earlier we can do typically about 200 plants an hour in our little head house here. And you can see I usually do the whole tray at one time. Now, especially if you're doing this on your own for home gardening, you probably don't want to do that. There is a limit to how many you want to do at once just to keep them from wilting. But a lot of times what we'll do is we'll take these 50 cell plug trays and we'll just cut them right down the middle so that they become a pack of 20 and a pack of 30. And that works really good for people that are a little bit slower at grafting because you can do 20 at a time or 30 at a time as you're doing this. Whoops. So here's those a little bit slowed down now. You can see these are some of rootstocks just lined up. But what I wanted to point out in this picture is one of the tricks that I've found that can be helpful for trying to make sure those angles of your cuts line up well. Now, one of the things that you'll find is that if you always graft from the same side, and I'm right-handed, so I'm going to always be grafting from the right-hand side, then I'll make a nice angle like that. And then when I go and put my clips on, I'll actually angle that clip perpendicular with the plane of the cut. And that's going to do a couple of things. The most important thing is when you insert a scion down into that clip, it's going to prevent it from sliding out the back side. If you had the opening at the bottom of that hill of the angle, then it's going to make it more likely that the scion could just flop out. So I like to have it perpendicular mainly because it holds it together nice and tight. But the other thing that I have found is helpful is if you leave it perpendicular with the plane of that cut, and when you come back and start inserting your scion, you know exactly what the angle is that you need to actually insert the scion down into the clip. And so that can be just a handy trick for being a little bit faster and making sure you get those things to line up well. So once you've actually done the slicing and dicing, this is when it starts becoming a little bit more fun. And again, basically what we need to do is allow the plant to heal itself and form that callus tissue and reconnect its vascular bundles and the plumbing tissues within the plant. And again, there's been some research in Spain that was done that showed that it takes somewhere around 7 days for that process to happen. So what we're trying to do with the healing chamber is basically change the physical environment so that scion tissue, that upper portion that doesn't have a root system anymore connected to it, doesn't need a root system anymore. And in many ways, it's a lot like growing vegetative cuttings in this way. When you're growing cuttings, you basically just need to keep that cutting alive long enough for it to grow roots, right? Well, in this case, we're not trying to grow roots. We're just trying to get those vascular bundles to reconnect. So basically what we can do is we can pump up the humidity and reduce the transpiration stream through the plant so that the scion tissue doesn't need a root system, at least temporarily, right? And we can do this by increasing the humidity around the plant and by reducing light. And of course you could with temperature, but we don't want to do that because we still want the plants to grow, right? So we like to keep our healing chambers actually a little bit warmer than our greenhouse. And we usually keep our healing chambers right around 75 degrees at night, whereas we keep the rest of our greenhouse about 68. And that's just going to help promote that growth within the healing chamber and help that process happen a little bit quicker. So I've got a whole bunch of examples of different healing chambers, and you can build these to any size and scale that you want. They're all kind of the same when it comes down to it. These are some chambers that we used to build in some internal grow rooms, but I think they're actually kind of useful for a home gardener because you could set something like this up in a garage space or in a basement, and basically all it is just a plastic film covered environment. We've got what's called a cool mist vaporizer down here with a PVC pipe actually in pumping the humidity into that chamber. Now it is important to not use warm water vaporizers. These are called cool mist vaporizers. And they use a different technology in order to create that humidity. And as a result, it won't heat up the chamber, which is really important. It also sends out a lot more humidity than a warm water vaporizer or a passive vaporizer like the ones that are driven by fans. This is my very, very first healing chamber I ever built, and there's lots of things wrong with it, but we won't point all of that out. But if you are doing this in a greenhouse space or somewhere where you can expose them to full sunlight, I really wanted to point out how important it is to keep the full sun off of a healing chamber. If you are allowing that double greenhouse effect to happen, then you will cook your plants really, really quickly. And we grew a lot of grafted plants with this, but the only reason we were successful is because this nifty camping tarp right here that was able to keep the full sun off of that healing chamber. So this is what the plants might look like when they're actually in the healing chamber. And on the right, what you can see are some plants that were just put in there. So they've actually wilted a little bit just from the process of grafting. And on the left, you can basically see plants that have been in the healing chamber already for an hour or two. And you can see how they've already popped up and they've regained their turgidity. And it's amazing. And actually, you expose these plants to this 90% plus humidity, they will pop back up just like balloons when you do that. So we've been using these dome trays quite a bit, and I think these are a handy system for a home gardener. And I've actually done 50 plant batches like this, and it works really well. These little domes you can buy at many of the different seed companies out there. It is important to note that there's tall ones and there's shorter ones, and you do have to use the taller ones for grafting because the plants will just be too tall if you use those shorter ones. But they work really well for basically just passively increasing the humidity. Now, one of the things you have to be careful with, again, you can see this is in a greenhouse, and so we're using foam to actually keep the direct sun off of those healing chambers, and that works just fine. But again, you do want to make sure there's no direct sun causing a double greenhouse effect to happen. This would be maybe more like what you guys might use in a home gardener situation. This is basically just a small heating mat, and then we've got some LED lights above this. And the first couple days you would not have those lights on, but then once they start to perk up and they get through those first initial 48 hours, then I would suggest actually having the lights on. It can be a nice way to prevent them from getting too tall and leggy, and also just promote that growth and healing process as well. We can also stack them vertically, can be kind of fun. This is a grower I worked with, and he used to grow about 500 grafted plants, so not a huge number. But if you team up with your neighbors or your master gardener groups, you guys could set something up like this in your greenhouse. And again, it's basically the same thing. You've got a plastic holding in the humidity. You got a cool mist vaporizer, and then they're using, this is actually just weed fabric that he's using to keep the direct sun off of the chamber. This is a little bit more high tech. This is at a propagation house I used to work with in Pennsylvania. And then this is a chamber that we built here in Kansas. Now, the reason I put this picture in, you can see we use a lot of this 9-gauge wire to make our little hoops. But this is one of the mistakes I made along the way. This is, I used a wooden frame for my base one time, and it turned out that apparently Botrytis really loves untreated pine, because this was the only time I've ever had Botrytis crop up in my healing chambers, and I'm just sure that it had something to do with the nasty pine that we were using for that frame. This is just kind of a cool picture. Sarah is one of my graduate students from a couple years ago, and she actually did research looking at different types of coverings for the healing chambers. So we use shade cloth plastic, shade cloth alone. We use some other types of plastics. You can see this white. This is like a nursery film. It's actually not a plastic at all. And so she did some kind of neat work with that, looking at how it affects the microclimate. And then we've also done a lot of work with leaf and shoot removal. And so you can see here, this is a grafted plant on the right. And basically what we did was we removed the meristematic shoot out of it in order to reduce that transpiration stream and hopefully reduce the water stress on the plant. Now, as it turns out, when you do this, if you cut the entire meristem out, it actually slows down the healing process by quite a bit. And so we found out that that's not really ideal. But we also tried it by just cutting a whole bunch of leaf material off. You can see this on the left, where we've left the meristem in there, but we've cut off pretty much all the leaf material. And this is something that's been really useful, both for increasing success. And you can see some of Sarah's data here. We saw significantly higher success with that grafting method using leaf removal. And then we've also found out that it's been a little bit useful for other things as well too. Now, this is a physiological phenomenon called edema, and it basically looks like this yellow bubbling on the leaves, and it's really a physiological problem. It's not a big issue if you see it start to pop up in the plants. Just take the plants out of the healing chamber. What it means is the root system is now officially connected to your scion, and it really is concerned about how much humidity is in the healing chamber. So it's not a big issue. It won't spread. You just have to take it out of the healing chamber at that point. Last but not least, this is something else that can happen in the healing chamber, all these adventitious roots. And we actually did quite a bit of research looking into this. And I had another graduate student that just graduated a couple years ago looking at how the humidity levels as well as leaf removal affects the adventitious root formation in the plants. And we found out some really interesting findings, but most importantly, that removing the leaves or trimming the leaves when we actually graft them helps reduce the adventitious roots by a pretty significant degree. And then the other thing that we found was that the lower the environmental humidity was, the less of a problem we had with adventitious roots as well too. So after they come out of the healing chamber, they do need to harden off for 10 days, 2 weeks, something like that. The clip will actually fall off on its own. It is a sort of like a rubber or silicone material, so it'll just open up on its own and fall off back into the tray. And you can usually collect them, and we wash ours with 10% bleach, rinse them real good, and then you can reuse them. When you actually start planting, you do want to be a little bit careful that the graft union is above the soil line. We always think about tomatoes as you can plant them very deep, but in this situation, if you do that, you could potentially lose the benefit of that rootstock. So you want to make sure that graft union is above the soil line. And then you do want to be careful for suckering. So you can see the sucker coming off of the rootstock of the plant. These plants, when they sucker, will grow very fast, and they'll actually start to sort of dominate your tomato patch. So you want to watch out for that. You can actually see here in this picture, this tomato right here, this is actually the sucker off of one of the rootstocks. And you can see the leaves are much bigger. They're quite a bit more pubescent. Again, this is a hybrid between a wild tomato and a domestic species. Now the grafted plants, depending on the rootstock you use, but if you use a vegetative one like Maxifort, the plants can get quite a bit bigger as well. So you just want to be careful that you've got, plenty of trellising, plenty of cages, whatever it is you're using to affix those tomatoes, be ready for a bigger plant. So, just to kind of bring all those things together, the key principles of success are, one, being able to grow the seedling nice and uniform, and also exposing to good high light conditions so that they're nice and sturdy and rigid. But then also being able to get those stem diameters to match up. So you have to keep a close eye on them. If you have the ability to manipulate their growing temperatures, that can be a really nice system for managing that. And a good way for home gardeners to do that is to use heating mats. If you have more than one heating mat, you can set them at different temperatures if you're growing in a cool environment, in order to speed up or slow down the ones that you want to make them fit. And then again, you always want to have good sanitation methods. We're going to be putting these plants through a lot of stress and then putting them into a very humid environment. And so we want to make sure that they're not diseased or nutrient stressed. And then again, there's no better way to learn how to deal with water stress in a tomato than cutting it from its root system and trying to get it to live. So, you try and do your best to observe them closely and respond to them. If you take a piece of shade cloth off, or you increase the light, or you turn up the temperature, go back and check on them 90 minutes later to make sure that they haven't started to wilt, or that they have a problem because of that. All right, well, I appreciate your all's attention today, and would be happy to take some questions.
Great. Thank you so much, Cary. I really liked how you blended some of the science in the background. It was really interesting to learn about the sugars and the acidity. So that was a lot of fun, and the practical aspects of doing this, right? So when I go out shopping at a garden center and I see these grafted tomatoes, now I know why they cost more. It's a very intense process.
And they do cost quite a bit more. It's amazing what they're selling those for.
Yeah, I can see why. This is intense. So I'm going to have you, if folks have questions, in the Q&A, and I'll read them off. I see quite a few questions about growing out tomatoes, and so I'm going to probably answer those offline and focus on the ones that are related to the specifics of grafting. So if I don't answer your question right now, that's why, and I'll circle back around to you because I have all of your emails. There were a couple of questions back kind of in the middle when you were talking about the importance of having the diameter of the scion and the rootstock. And so what happens if they don't match up? What do you see? Is it just,
Yeah, so, if you think about the tissues of the stem, right, the xylem and the phloem, they're not going to match up very well if all it takes is a small difference in the diameter of the plant for those things to suddenly not line up, right? And so some of it is just lining up the plumbing tissues. But to be honest with you, the biggest challenge is if they're not the same, then the clip is going to hold on to one and it's not going to hold on to the other. And so a lot of it's just the logistics of that little clip holding the two stems together. They have to be almost identical, or else one of them is going to fall out, basically.
Gotcha. Let me see. And then can you just reiterate the number of leaves to have when you're making these cuts? Is it 1 to 2 or true leaves, or you have
Yeah, so it's usually around 2 or 3
Two to
truly,
three.
yep,
Great.
something like that.
And let's see. You had mentioned on sanitation, so Valerie had a question on the bleach. So I know that the grocery store bleach that we have might be a different percent.
Right.
And so it's whatever you have. Are you diluting it to 10%, or are you purchasing like a special?
Yeah, we're just purchasing grocery store bleach and diluting that, 9 to 1 basically.
Great. So Carol has a question about the rootstocks and the varieties and how we will see them sold as this is a grafted tomato.
Right.
But she's asking, since the rootstock variety is important and it sounds like it's specialized to the needs, how do they go about finding that? Is there like standards that nurseries are using, or?
Yeah, that's a great question and an excellent point. It's a lot of people, whenever we talk about grafting, they focus on the wrong word, right? It's all about grafted this and grafted that. It should be all about rootstock this, then rootstock that. 'Cause that's the real benefit, right? So most of the nurseries that are selling grafted plants, it depends if they're growing their own grafted plants, or I know there's a couple of large nurseries on the West Coast that are producing, pretty large amounts and then shipping them to nurseries. There was a long time that nursery wouldn't tell us what rootstock it was because it was proprietary. But then more recently, they've begun to actually, tell us what their rootstock is. So it's a little bit unknown, but I think there's so few actual nurseries selling to the home garden market that most of them are probably using one or two rootstocks that are out there. Now, my understanding is those ones that are coming to most of the garden centers are being grown on a rootstock called Supernatural. And then it wouldn't surprise me if people are going to use Maxifort or Multifort, because those are two just extraordinarily popular and available rootstocks that tend to show pretty reliable yield increases. Now, we've done research with all three of those rootstocks, and they've all had pretty good success in low disease situations. But other than that, yeah, I think you just have to ask questions to wherever nursery you're going to get them from, find out what rootstocks they're looking at. And chances are that they may or may not know, depending on
That's
if
true, right? Yeah.
Yeah.
So maybe
yeah,
if you're trying to deal with a disease issue through a rootstock, this might not be, if you can't find out what the name is, right? It might not be the
absolutely.
best situation.
Right.
Yeah.
Definitely. Now, most of the rootstocks, they tend to blend together, resistance to most of the important soil-borne disease pathogens. But there's a couple of really important diseases that can make or break your rootstock selection. One of them is bacterial wilt, but in Oregon, you guys wouldn't be dealing with that at all, right? I mean, I'm sure you don't have that issue. So that's hopefully nothing to worry about too much. And then the other one is root knot nematodes. That there's a huge degree of specificity with that pathogen in the root system that we're starting to see with our rootstocks. So if that was a disease you're concerned about, you might want to ask some more questions as well too. The other thing that brings up that I didn't mention earlier is, keep in mind if you're just grafting at home for your own production, if you're growing heirlooms that are susceptible to some of these diseases, and you have a certain disease that you're trying to manage, you can always just go buy a hybrid tomato that's resistant to that disease and graft it. And you don't necessarily have to go buy these interspecific hybrid rootstocks. You could just go buy a better boy. If Fusarium is your problem, then there's lots of cherry tomatoes out there with Fusarium resistance. You could just use that as a rootstock.
Oh, okay. And then there's two questions on the rootstock. So Kim and Donna both want to know, where can you get these specific, do they sell garden size packets? I know you probably deal with like pounds of tomato seed most likely. Are there places that folks can get these?
Yeah, so there's a couple of options. There was actually a company, I haven't heard from them for a couple of years. There was a company in North Carolina that started actually putting together home gardener packs of rootstock seed, clips, and other things that you need into a little pack of like 20, I think. And they would send them out to home gardeners as sort of a do-it-yourself grafting kit.
Oh,
Unfortunately, I cannot remember the name of that company right now, but folks may be able to find them online. It was a small company in North Carolina that was doing that. I'm pretty sure that Johnny's sells Maxifort and other rootstock seeds in packets of 25.
okay.
Part of the challenge is the less rootstock seed you buy, the more expensive it becomes. I think it's upwards of 50 cents a seed when you buy those
Ooh,
small packets. So
right.
just be aware to get ready for some sticker shock there. So
Like
yeah,
all good hobbies, it comes with
yeah,
a
that's
price,
right. That's
right?
right. Tomatoes are a labor of love. It's,
That's
you
true.
know.
Um, so we have a couple more minutes if you've got a minute.
Oh, and it looks
So
like somebody's commenting there that Territorial also has small packets as well.
yeah, and so Jennifer had a comment on, she was looking to compare some rootstocks, and so it's Estamino and
Mhm.
Submarine. Have you had any experience in
Yeah.
your trials on those?
We've grown Estamino quite a bit. I have not grown Submarine. So apparently I need to call up Territorial and see if I can get my hands on those. Um, Estamino is what we would call a generative rootstock. So it's not as high powered and vegetative as something like Maxifort or Colossus. But I usually recommend Estamino for people that are grafting onto heirlooms. Heirlooms and other indeterminates that are really vegetative, we actually kind of want to slow down the growth with those. And so Estamino actually, it sounds counterintuitive, but that's, you don't necessarily want this huge tree of a plant, right? Estamino does a better job of getting some of that energy pushed into fruit production because it's a more generative rootstock. So it can be a nice one for those heirlooms. But I'm not familiar with Submarine. I think I need to try it out.
Okay. And I don't see this question asked, but I have to ask it. So we have folks that are selling grafted tomatoes and potatoes. Do you
Oh,
have
yeah.
any, any thoughts on these? And they're crazy expensive. They're like
Yeah.
$25 maybe for a plant.
Right.
So they can do this. I mean, it's successful. Save.
Apparently it
Yeah.
works. And I've seen pictures at least of some pretty nice looking potato crops. It's hard for me to believe that you would think either the potatoes would do well or the tomatoes would do well, and maybe not so much both.
Both. Yeah.
Here in Kansas, our problem is we don't grow potatoes and tomatoes at the same time of year.
Oh, okay.
Right? I mean, potatoes is much more a cool season plant. And so it would never work here because
Right.
it gets too hot in the summer and it's too cool in the spring. So, but
Mm.
yeah, I mean, something fun to do for sure.
Yeah. Awesome. All right. Well, we are right at the top of the hour. I do see there's a few more questions. And so what I'm going to do is take a look at those ones that I can't answer. I might just shoot you an email and we'll get an answer back to folks if they have some specifics. A couple of people were asking if it was recorded, and it is recorded. I missed just a little bit of your introduction, so I might backfill that on the recording. And everyone, if you would just look for an evaluation survey that will come out, and then hold the date for our next webinar, which is April 30th at 11 Pacific, and it's on adapting dry farming techniques to home gardens with Amy Garrett from OSU. And you can't hear us clapping, but we're clapping, and we're really appreciative. Cary, thank you so much for an excellent presentation.
No problem. Thank you for the invitation. It was great to
All
see
right.
you.
Great, you too. And we'll see you all next month. Thank you.